Imagine waking up one morning to find that time as you know it has vanished. There are no clocks, no watches, and no way to tell the time. The sun rises and sets, but you have no idea how long it has been since you woke up or how much longer you have until nightfall. This is the world that existed for most of human history. It's hard to believe, but for thousands of years, people had no precise way to measure time. They relied on the sun, the moon, and the stars to mark the passing of days, but the concept of hours, minutes, and seconds was entirely foreign. The invention of the water clock, or clepsydra, was a groundbreaking moment that changed everything. The ancient Greeks were masters of engineering and mechanics. They had already perfected the sundial to measure daylight, but they needed a more reliable way to keep track of time, especially during the night and on cloudy days. This is where the water clock, or clepsydra, came into play. The Greeks called it a water thief because it seemed to steal away the hours with its steady flow of water. The water clock worked by allowing water to drip from a container at a constant rate. As the water level dropped, it would mark the passage of time. The Greeks used these clocks to regulate various aspects of daily life, including the timing of court proceedings. Demosthenes, a famous Greek orator, often pleaded for the water flow to be stopped while he read from laws or depositions. This way, he wouldn't run out of time to make his case. The Tower of the Winds in Athens, a remarkable structure, had a circular cistern attached to it as a reservoir for a water clock. This elegant design allowed the clock to function seamlessly, marking the hours with precision. The Romans, too, were adept at engineering and mechanics, and they adopted the water clock as a crucial tool for measuring time. They Latinized the Greek term clepsydra to clepsydra, or horologem ex aqua. The Romans made significant improvements to the water clock, turning it into an everyday convenience. They even made miniature sundials that could fit in a pocket, and they built grandiose structures like the obelisk on the Campus Martius, which served as a giant sundial. The Romans, being practical and commercial people, understood the value of time. However, they initially divided their day into only two parts: before midday, ante-meridum, and after midday, post-meridum, PM. An assistant to the consul would announce when the sun crossed the meridian, a crucial moment for lawyers who needed to appear in court before noon. Over time, they made finer subdivisions, dividing each half of the day into more specific parts: early morning main, forenoon ante-meridum, afternoon demeriti, and evening suprema. The Romans also brought a sundial from Catana in Sicily to Rome, but it was not very accurate due to the difference in latitude. In 164 B.C., the censor Q. Marcius Philippus set up a properly oriented sundial in Rome, and a water clock was installed to tell time on foggy days and at night. The water clocks, however, still measured temporary hours, with daylight and darkness measurements that varied from day to day. Despite these challenges, the Romans managed to create a system that served their daily needs. The hours of their daily lives were more elastic than we can imagine. At the winter solstice, the first hour of their day, hora prima, began at what we would call 7:33 a.m. and lasted only till 8:17 a.m., while the 12th hour, hora duodecima, began at 3:42 p.m. and expired at 4:27 p.m. This meant that the length of an hour was not constant, but changed with the seasons. The Romans used elaborate systems to calibrate their water clocks to reflect these changes, but it was far too complicated to mark the shifting increments from day to day. In the Roman courtroom, the water clock served as a simple yet effective timer. Lawyers were given equal time to present their cases, and a bowl with a hole near the bottom would empty in about 20 minutes. A lawyer might ask for additional 6 clepsydri, or about 2 of our modern hours, to make his case. A particularly long-winded advocate might be granted up to 5 hours, but this was rare. The phrase "to grant water" meant to allot time to a lawyer, while to lose water meant to waste time. If a speaker in the Senate spoke out of turn or talked too long, his colleagues would shout that his water should be taken away. The Romans were also known for their ingenuity. To prevent the escape hole from wearing away or clogging, they used a gem to fashion the hole, much like later clockmakers used jewels. Some Roman water clocks were fitted with elaborate floats that would announce the Roman hour by tossing pebbles or eggs into the air, or by blowing a whistle. The water clock became a symbol of status, and wealthy Romans would display them in their homes. The parvenu Trimalchio, a character from the age of Nero, was admired for having a clock in his dining room, complete with a uniformed trumpeter to announce the passing hours. In other parts of the world, people found their own ways to measure time. The Saxons in the 9th century used a bowl of water with a small hole in the bottom. The bowl would float and sink as it filled, marking the same period each time. The Chinese, who had their own simple water clocks from ancient times, brought back tales of elaborate striking water clocks from their travels. One such clock, at the east gate of the great mosque in Damascus, used falcons and brass balls to announce each hour, with lamps that lit up at night. This clock required the full time of 11 men to keep it running. The use of water to measure time eventually gave way to the sandglass, which became a popular metaphor for the passing hours. Sand was less fluid than water, and did not require the same level of calibration. The first sandglasses appeared in Europe in the 8th century, supposedly invented by a monk at Chartres. As glassmaking progressed, it became possible to seal the hourglass to keep out moisture, and the sand was dried to ensure a consistent flow. Sandglasses were particularly useful for measuring short intervals, such as the duration of a sermon or a ship's speed. Columbus used a half-hour sandglass on his ships to keep track of the canonical hours, and by the 16th century, sandglasses were being used in kitchens to regulate cooking times. The House of Commons kept a 2-minute glass to time the ringing of bells for voting, and stonemasons used them to count their hours of work. Teachers brought hourglasses to measure the duration of their lectures, or the length of study periods. In Oxford, Don once threatened his students that if they did not improve their performance, he would bring an hourglass that lasted 2 hours. The sandglass was also used to measure a ship's speed. Knots were tied at 7-fathom intervals on a line tied to a log chip. A sailor would drop the log chip off the end of the ship and count the number of knots that passed, while a small sandglass measured a half-minute. This method, known as heaving the log, was used to determine the ship's speed in nautical miles per hour. The sandglass, however, was not ideal for day-long timekeeping. It had to be turned frequently, and if it was small, it had to be turned at the precise moment when the last grain of sand had dropped. Some sandglasses had a dial with a pointer that could be advanced with each turn, but this was not always practical. People also tried to combine timepieces with lighting devices to measure the hours of the night. One famous example was the candle clock designed for King Alfred the Great of England. Alfred, after a period of exile, vowed to devote a third of each day to the service of God. He ordered a candle clock made from 72 pennyweight of wax, divided into 6 12-inch candles, each marked in 1-inch divisions. The candles were lit in rotation and protected by transparent horn panels to prevent drafts from extinguishing the flame. If Alfred devoted the time of 2 full candle lengths to his religious duties, he could be sure he was fulfilling his vow. Other sovereigns, such as King Alfonso X of Castile, King Charles V of France, and King Philip I of Spain, experimented with clock lamps. The Milanese physician Girolamo Cardano invented a fountain feeding device that used the principle of the vacuum to draw in a constant flow of oil. Cardano's lamp provided a convenient and popular lighting device until the late 18th century. In China, Japan, and Korea, the use of fire to measure time took a different turn. The custom of burning incense led to the invention of aromatic clocks. These devices produced a pleasing aroma, while a continuous trail of powdered incense burned in an elaborate seal. The time was indicated by the place within the seal that was reached by the fire. The 100 gradations incense seal, invented in China in 1073, was particularly intricate and beautifully designed. These clocks were a delightful byproduct of the effort to make a virtue of the variant hour. The struggle to measure time accurately continued even after the invention of the mechanical clock. Inventors tried various methods, such as using the flame of an oil lamp to propel the mechanism of a clock, or using the consumption of oil indicated on a calibrated transparent container. Some even used the changing shadow of a diminishing candle, cast on a scale to mark the passing hours. In the end, the mechanical clock revolutionized the way people measured time. The invention of the mechanical clock in the 14th century marked a significant milestone in the history of timekeeping. For the first time, people had a way to measure precise, equal hours, minutes, and seconds. This allowed them to live by the hour, and eventually by the minute. The mechanical clock made it possible to regulate daily life with greater precision, from the timing of work and school to the coordination of transportation and communication. The rise of the equal hour was a gradual process. While man had long been a slave to the sun, the mechanical clock allowed him to become the master of his time. The invention of the mechanical clock was a turning point that changed the way people lived and worked. It allowed them to slice their lives into neat, usable portions and to assimilate night into the day. The mechanical clock was a machine that marked the passage of time with precision, making it possible for people to live in a world where time was not just a natural phenomenon, but a tool to be used and controlled. In conclusion, the journey from the water clock to the mechanical clock is a story of human ingenuity and the relentless pursuit of precision. From the simple water clocks of the ancient Greeks to the elaborate incense clocks of China, people have always sought ways to measure the passing hours. The invention of the mechanical clock in the 14th century was a watershed moment that transformed the way we live and work. Today, we take for granted the ability to measure time with precision, but it was a long and challenging journey to get here. The history of timekeeping is a testament to human creativity and the desire to master the natural world.